travels along a straight line. And we also know that when light falls on an object, it will be reflected by the surface of that object, and if that reflected light reaches our eyes, we can see that object. Let's learn more about the reflection of light and how images are formed from the lesson Light, Class 7 Science in this session. Learning outcomes. At the end of this session, you will be able to understand about reflection of light, laws of reflection, making our periscope, image formation in mirror, lateral inversion, size of the image, multiple images, reflection, the phenomenon of light bouncing off surfaces, incident ray, a ray of light that falls on any surface, reflected ray, light ray that bounces off a surface, normal, the perpendicular drawn to the reflecting surface, angle of incidence, the angle between the incident ray and the normal at the point of incidence, angle of reflection, the angle between the reflected ray and the normal at the point of incidence to a reflecting surface, image, lateral inversion, the interchange of the left side and right side in the image of the object when reflected by a plane mirror, periscope, an optical instrument that uses a system of mirrors to reflect images through a tube. Before starting, let us look at the concept map for this session. To understand the reflection of light, let's do an activity. Place a blank sheet of paper on the ground. Hold the mirror strip with the slit facing the sun. Let a ray of light from the slit fall on the paper. Now, take another mirror strip and place it in the path of this light ray such that the ray coming from the first mirror falls on the second mirror. We see another ray of light apart from the one from the mirror slit on the paper. This effect of the mirror strip on the ray of light is called reflection. The ray of light falling on the mirror is called the incident ray. And the ray returning from it is called the reflected ray. Let's understand the laws of reflection by doing an activity. Take a blank paper. Draw line segment AC. Draw another straight line at right angle 90 degrees to segment AC. The second line should intersect segment AC at point B. We call this line as normal. Draw two lines from point B on the left side of the normal and two on the right side at angles of 30 degrees and 60 degrees respectively. Number these lines 1, 2, 3 and 4. Place a mirror strip vertically on segment AC with its reflecting surface facing the normal. Take the mirror strip with a slit and let its light ray fall along line 4. This ray is the incident ray for the mirror. The angle between normal and the incident ray is called the angle of incidence. Angle I. The reflected ray falls on the line 1. The angle between the normal and the reflected ray is called the angle of reflection. Angle R. Adjust the mirror strip with a slit so that its light ray falls along line 3. We observe that the reflected ray falls on the line 2. Adjust the mirror strip with a slit so that its light ray falls along normal. Then the angle of incidence is 0 degrees. We find the reflected ray along the normal itself. We find that the angle of incidence is equal to the angle of reflection. The incident ray, reflected ray, and normal lie in the same plane. Periscope is based on the principle of the law of reflection of light. For making a periscope, let's take a rectangular box, two mirror strips, a scale, a pencil, a blade and molten wax. Close both ends of the rectangular box. Draw squares at both ends. Draw the diagonal to these squares. Slit the diagonals with a blade. The slits should be equal to the length of the mirror strips. Fix the mirror strips firmly in these slits with a few drops of molten wax. The mirror strips should lie parallel to each other with their reflecting surfaces facing each other. Cut out two windows on the narrow sides of the box. The windows should open directly on the reflecting surfaces of the mirror strips. The mirrors should be kept in parallel only because the incident ray for the second mirror is the reflected ray of the first mirror. When these two mirrors are parallel to each other, only the rays lie in the same plane and can pass to the windows of the periscope. Now the periscope is ready. When you look through window 2, you will be able to see things lying in front of the window 1. You would have seen your image in a mirror. Do you know how it is formed? Light that falls on you gets reflected, and several reflected light rays from you that fall on the mirror also get reflected back. These reflected rays reach your eye and make you see your image. Thus, the formation of images in mirrors is due to the reflection of light rays from the mirror. The figure on the screen explains how the image of a candle is formed in the mirror and how you can see the image of the candle in the mirror. To know what lateral inversion means, stand in front of a plane mirror and look at your image. Raise your left hand and observe which hand does your image raise. Now touch your right ear and observe which ear does your hand touch in your image. You will find that in the mirror, the right appears left and the left appears right. Note that only sides are interchanged. The image does not appear upside down. This is called lateral inversion. This is why the word ambulance is written as shown on the screen. To understand the size of the images formed, stand in front of a mirror. Observe your image. Step back 2 feet and step forward 1 foot. You observe your image also moves. You will find that the image is at the same distance behind the mirror as the object is in front of it. What can you say about the size of your image when you stand in front of a small and big mirror? Irrespective of the size of the mirrors, the size of the image and the size of the object are equal. To understand how multiple images are formed, take 2 plane mirrors and keep them perpendicular to each other. Place an object between them. You can see 3 images of the object. You observe that for an object kept in between 2 plane mirrors, which were inclined to each other, you could see many images. This is because the image formed by one mirror acts as an object for the other mirror. The image formed by the first mirror acts as an object for the second mirror, and the image formed by the second mirror acts as an object for the first mirror. Thus, we have 3 images of a single body. The number of images increase when we reduce the angle between 2 mirrors. Kaleidoscope is a device that functions on the principle of multiple reflections of light to produce numerous patterns of images. Points to remember. Light changes its direction when it is obstructed by any object. This phenomenon is called reflection. The ray of light falling on the object is called the incident ray, and the ray returning from it is called the reflected ray. The angle of incidence is equal to the angle of reflection. The incident ray, reflected ray, and normal lie in the same plane. In the image formed by a mirror, the right of the object appears as left and the left of the object appears as right. This is called lateral inversion. Irrespective of the size of the plane mirror, the size of the image in the mirror is equal to the size of the object. Plane mirror forms a single image. If you want to form multiple images, 2 plane mirrors need to be kept at an angle. The number of images increases when we reduce the angle between two mirrors. Thank you.